Hi everybody and welcome to my channel. In this video we are going to be solving the grade 12 mathematics past exam paper from November 2024. So let's begin with our first question. The first question says solve for x, and we are given a quadratic equation in factored form where x is being multiplied by x minus 3 and giving us a 0. So in this case, every time when you have factors which are being multiplied and giving you a product of 0, what it means is either one of the factors is equal to 0 or both of the factors are zeros. So in this case, we have either x is equal to 0 or x minus 3 is equal to 0. So the x equal to 0 becomes our first solution, and solving the other factor gives us x is equal to positive 3. So these are our two answers: x is equal to 0 or x is equal to positive 3. Let's move on to the next question, which is 1.1.2. In question 1.1.2, we are given another quadratic equation: 2x to the power 2 plus 1 is equal to 4x. And your answer should be rounded to 2 decimal places. So this implies that we have to use the quadratic formula. So let's rearrange our equation and take everything to the left side. So we are going to have 2x to the power 2 minus 4x. The x initially it was a positive, and now when you bring it to the left side it becomes a negative. Then plus positive 1 being equal to 0. And now let's go to our quadratic equation, which says x is equal to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. So what we need to do is to identify our a, b, and our c. In this case, our a is the coefficient of the leading term, which is 2. So our a is 2, and our b is the coefficient of x. In this case, it is negative 4, and our c is the constant term that we have, and in this case it is positive 1. Now let's substitute these numbers, these values, into our quadratic equation. So our b is already negative, so it's going to be minus 4 plus or minus the square root of b, which is negative 4 to the power 2 minus 4 ac. Our a is 2 multiplied by c, which is 1, and everything being divided by 2a, and our a is positive 2. Now let's simplify it. So the first number is going to change into a positive 1. So we're going to have positive 4 plus or minus the square root negative 4 to the power 2, that's positive 16, minus 4 multiply 2, that's 8, multiply 1, it remains 8, divided by 2 multiply 2, that's 4. And it can be simplified further into 4 plus or minus the square root of 16 minus 8, that's 8, everything divided by 4. Now let's break down our answers. So because we have a plus or minus here, we're going to have two options. So we're going to have 4 plus the square root of 8 divided by 4 is our first answer. And we're also going to have 4 minus the square root of 8 divided by 4. And if you punch the first one in the calculator, is going to give you an answer of 1.71 when you round it to 2 decimal places, as the question says here, around 2 decimal places. And the second one, when rounded off to 2 decimal places, it will give you 0.29. So these are our 2 answers for question 1.1.2. Let's move on to the next one, 1.1.3. 1.1.3, we are given an inequality, quadratic inequality, whereby we have x to the power 2 minus 2x minus 3 being greater than 0. So the first thing that you need to do when solving a quadratic inequality is to make sure that the leading coefficient is always positive. So in this case, our leading coefficient is already positive 1, because we don't have a number written here. So when there's no number written, it means it's 1. And you also need to consider the sign that you are given. In this case, it is a greater than sign. So we are going to find what are called the critical values. Critical values. So let's take our inequality and turn it into an equation. So let's change the inequality sign into an equal sign and try to solve this. So we need to factorize. And how do we do that? We look at the leading coefficient, which is 1, and we multiply that 1 with the constant term, which is -3 in this case. So that gives us -3. 1 multiplied by -3 is -3. Then we need two factors of -3. So two numbers that if we multiply, they will give us -3, but if we add them, they will give us -2. And those numbers are the numbers that we're going to write here inside our brackets next to x. So you will find that the two numbers are -3 and +1. Because if you multiply -3 multiplied by 1, you get -3. And if you add -3 multiplied -3 plus 1, it gives you -2. So we're going to solve this. So we're going to have either x minus 3 being equal to 0, and solving this gives us x equal to 3. So this is our first critical value, and the second one is x plus 1 is equal to 0, and solving this gives us x equal to -1. So now we have our two critical values. So what do we do with these critical values? Because our inequality sign was a greater than sign, it means our solution is going to be x is going to be less than the smaller number between our two critical values. And between 3 and -1, the smaller one is -1. So x will be less than -1, or x will be bigger than the bigger number between the two critical values. In this case, the bigger number is +3. So this is our answer. And in most cases, the answer is written as, the R is written as a union sign, and this one is x plus 3, x greater than 3. If you want to write your answer in a graphical form, so you can draw a number line, and on this number line, on the left side you put -1, and on the right side you put +3. And because our inequality sign is a single line, it's less than, not less or equal to, we are going to draw an empty circle on top of -1 and draw an arrow pointing to the left side. And we are going to do the same on +3, draw an empty circle and draw an arrow pointing to the right side. So you can leave your answer in this form or in this form, whichever way that you feel comfortable to do. So this is our solution to question 1.1.3. Now let's carry on. Now we are on question 1.1.4, in which we are given in exponential equation 2 to the power 2x minus 2 to the power x plus 2 minus 32 is equal to 0, and they want us to solve for x. So we are going to apply the laws of exponents. So let's rewrite the 2 to the power 2x as 2 to the power x, everything raised to the power 2, and minus the 2 to the power x plus 2 can be rewritten as 2 to the power x multiplied by 2 to the power of 2, minus 32. Let's keep the 32 as it is. And now you can see that we have 2 to the power x here and another 2 to the power x here. So let's use any letter that we can use, and let's try to turn this into a quadratic equation. So let's say maybe let m is equal to 2 to the power of x. Now let's replace everywhere where you see 2 to the power x, let's replace it with m. So our new equation becomes m to the power of 2 minus, this is going to be m multiplied by 2 to the power 2, that's 4, minus 32 is equal to 0, which can be rewritten as m squared minus 4m minus 32 being equal to 0. Now we have a quadratic equation which we can solve. Now how do we solve this quadratic equation? We can solve it by factorizing. So let's try to factorize first. So how do we factorize? We know we have to put m here and we have to put m here. And the reason why we're putting both m's here and here is because our leading coefficient is 1. So if our leading coefficient was not another coefficient which is not 1. So in this case we multiply the leading coefficient which is 1, we multiply it with the constant term which is negative 32, and that gives us negative 32. And we want two factors of negative 32. Rather, we want two numbers that if we multiply we get negative 32, but if we add them we get negative 4. And those two numbers are negative 8 and positive 4. If you multiply negative 8 multiplied by positive 4, you get negative 32. And if you add negative 8 plus 4, it gives you negative 4. And let's solve this. So we're going to have either m minus 8 is equal to 0, and transferring 8 to the right side gives us m is equal to 8. This becomes our first solution for m. Or we are going to say m plus 4 is equal to 0, and solving this will give us m is equal to negative 4. But remember, we are solving for x, not for m. So what we need to do is to go back to our equation where we let m be equal to 2 to the power x, and we know that we said 2 to the power x is equal to m. Now let's replace m with 8. Let's start with 8. So this is going to be 8 is equal to 2 to the power x, and 8 can be rewritten as the power of 2. So 8 is 2 to the power 3, which is equal to 2 to the power x. And according to the laws of exponents, since the bases are the same on either side of our equation, it implies that our exponents should be equal. So this implies that 3 is equal to x, or x is equal to 3. So this is our first solution, first value for x. And then let's try the same with m being equal to negative 4. So we are going to say, Now let's try to replace m with -4, and you should be able to quickly realize that there's no value of x that if you put here and raise 2 to the power that value and get -4. Why? Because the graph of 2 to the power x is increasing something like this, and the graph is always above the x-axis. So this graph will never be negative. So this is the graph for 2 to the power x. So this value of m does not give us a solution. So there's no solution when m is -4. Another way of verifying that we don't have a value of x when m is -4 is by applying the logarithms. So what you can do is apply logarithms on both sides. So you're going to have logarithm of 2 to the power x is equal to the logarithm of -4, and we know that we don't have logarithms of negative numbers. Bringing down x would give you x logarithm of 2 is equal to the logarithm of -4, and x being equal to the logarithm of -4 divided by the logarithm of 2. And since we don't have logarithms of negative numbers, still this will lead to a no solution. That's it for question 1.1.4. Now let's move on to the next question. Now let's move on to question 1.1.5. In this case, we are given a radical equation, the square root of -2x plus 4 minus x being equal to 2, and they want us to solve for x. So the first thing that we do is to separate and isolate the radical and keep it on one side. So let's transfer the -x to the right side. So on the left side, we're going to remain with -2x plus 4 being equal to, when we transfer the -x to the right side, it becomes +x plus 2. Now, how do we get rid of the radical symbol? We have to square both sides, because in this case it is a square root sign, so we have to raise both sides to the power of 2. And squaring the left side simply eliminates the radical sign, so we are going to remain with -2x plus 4 is equal to, now let's expand the right hand side where we have x plus 2 in brackets to the power of 2. So it's going to be x to the power of 2 plus, because we have a plus sign here, we have to put the same sign. We multiply 2 with this 2 to get 4, and multiply it with x, so it becomes 4x plus, and we take 2 and raise it to the power 2, which is 4. Now let's transfer everything to one side. So let's move the terms on the left side to the right side. So we're going to have 0 is equal to x to the power of 2 plus 4x plus 4, and the -2x, when we transfer to the right side, it becomes positive. So plus 2x, and the +4 will change into a -4. Now let's combine the like terms. So we're going to have 0 is equal to x to the power 2 remains x to the power 2. So 4x plus 2x, this will give you 6x. And the constants will cancel each other. 4 minus 4, that's a 0. So we are left with a quadratic equation, x squared plus 6x being equal to 0. And how do we solve this? We have to factorize. So our equation is x squared plus 6x being equal to 0. So now we need to take the common factor. The common factor between x squared and 6x is x. So take the x out. What's going to remain inside the bracket is x plus 6 being equal to 0. And like we did in the first question, we are going to have two options. So we're going to have either x is equal to 0 or the bracket x plus 6 being equal to 0. And solving x plus 6 equal to 0 gives us x is equal to negative 6. So these are our two answers, our two values of x that we have got. But we need, since it was a radical equation, we need to check if both our solutions do work for this particular question. So what we need to do, we need to check our answers and see if they satisfy this radical equation. So let's start with 0, with x is equal to 0. We are going to replace x with 0 in our original equation. So, and compare the left side to the right side. So we're going to have the square root negative 2 multiplied by 0 plus 4 minus our x is 0. Is this equal to 2? So we need to verify this. So this becomes the square root of negative 2 multiplied 0, that's 0, plus 4, that's a 4, minus 0, we don't need to write the 0. Is this equal to 2? Yes, the square root of 4 is 2, so 2 is equal to 2, which is true. So this implies that our solution of x being 0 is indeed correct. Now let's do the same for x equal to negative 6. So let's replace again our x with negative 6. So we have minus 2 multiplied by negative 6 plus 4 inside the square root minus our x is a negative 6. So this one will be negative 6. Is this going to give us a positive 2? We need to check. Square root of negative 2 multiply negative 6, that's positive 12 plus 4. Negative multiply negative, that's positive. So with plus 6 being equal to 2, this becomes the square root of 16 plus 6 being equal to 2. And the square root of 16, that's 4 plus 6. And 4 plus 6, that's 10. And 10 is not equal to 2. Therefore, x cannot be negative 6 because this value of negative 6 for x has failed to satisfy our original equation. So what it means is x is equal to 0 is our only solution. That's it for question 1.1.5. Let's move on to the next question. Now moving on to question 1.2, we are given a simultaneous equation whereby 2x plus y is equal to 3 and y to the power 2 plus xy being equal to positive 2. So let's solve this. So we are going to solve this by substitution. So we are going to take the first equation and isolate the variable y. So y is equal to 3 and transfer the 2x to the right side, it will be negative 2x. So y is equal to negative 2x. Now we take this value for y, 3 minus 2x, and we replace it in the second equation. Where we see y, we are going to replace it with 3 minus 2x. So we are going to have 3 minus 2x to the power 2, because it was y to the power 2, plus x multiplied by, now instead of writing y, we are going to write 3 minus 2x, close bracket, is equal to positive 2. And let's expand. When you square 3 minus 2x to the power of 2, it will become 9 minus, then you multiply this 3 with 2. 3 multiply 2 is 6, and 6 multiply 2 is 12. So we're going to put 12x here, and then plus, because now we are squaring a negative number. Every squared number is always positive. So 2x to the power 2, that's going to be 4x squared. Now let's expand the second expression. X multiplied 3, that's 3x, minus x multiplied by minus 2x, that's going to be minus 2x to the power 2, being equal to 2. Let's transfer the 2 which is on the right side, let's take it to the left side and remain with 0 on the right side. So we are going to have 9 minus 12x plus 4x to the power 2 plus 3x minus 2x to the power 2 minus 2 being equal to 0. Now let's combine the like terms and rearrange our equation. So 4x to the power 2 minus 2x to the power 2. This is going to be 2x squared. 3x minus 12x. This is going to be minus 9x. And 9 minus 2. This is going to be positive 7, being equal to 0. Now we have a simplified quadratic equation. And we can solve this by factorization. Let's try to factorize it first. So we have, in this case, our leading coefficient is not 1, it is positive 2. So we take 2 and multiply it with our constant term, which is 7. So 2 multiply 7, that's 14. So we need the factors of 14, which if we add, we get negative 9. So we want two numbers. That if we multiply we get positive 14, but if we add them we get negative 9, and those two numbers are negative 7 and negative 2. So we are going to say 2x to the power 2. So we have negative 7 and negative 2, or negative 2 and negative 7. The order doesn't really matter in this case. So negative 2x, negative 7x plus 7 is equal to 0. And let's factorize each pair. So the first pair is 2x to the power 2 minus 2x being equal to then the second pair is negative 7x plus 7. So let's factorize this and also factorize the second pair. So 2x is a common factor between 2x squared and minus 2x, and inside the bracket we're going to remain with x minus 1, and the second bracket also has to be x minus 1 if it is possible to factorize this, and our common factor will be negative 7. Negative 7 multiply x, that's negative 7x. Negative 7 multiplying negative 1, that's positive 7. And completing the factorization gives us x minus 1 multiplied by 2x minus 7 being equal to 0. And then, like we did before, we're going to have two options. Either x minus 1 is equal to 0, and solving this will give us x being equal to 1. And the second option, 2x minus 7 equal to 0, and solving this gives us x equal to 7 over 2. These are our two values of x. So we have the two values of x, and now we need to find the corresponding y values. So how do we do that? We are going to go back to our equations and replace. Let's start by replacing x is equal to 1. So let's go to this equation where we put y, we isolated y being equal to y is equal to 3 minus 2x. So we know that y is equal to 3 minus 2x, and our first value of x is 1, so y will be 3 minus 2 times 1, which is equal to 3 minus 2, which is equal to 1. So when x is 1, y is 1. So 1 for x and 1 for y. This is our first solution, our first set of solutions. And the second one, let's replace x with 7 over 2. So we are going to have y is equal to 3 minus 2 multiplied by 7 over 2. And these 2 will cancel with these 2. We are going to have y being equal to 3 minus 7, giving us y is equal to negative 4. So when x is 7 by 2, y is negative 4. This is another set of our solution. So when x is 1, y is 1, and when x is 7 over 2, y is negative 4. That's it for question 1.2. Moving on to question 1.3, we are given a question which reads, consider the product 1 plus 1 over 2 multiplied by 1 plus 1 over 3 multiplied by 1 plus 1 over 4 and so forth. Each factor in the product is of the form 1 plus 1 over n, for n is greater or equal to 2. Now the question continues on to say, determine all the values of n for which the product will be an integer value. So let's try to simplify this fraction. Let's combine this fraction into an improper fraction. So the first bracket, if you add 1 plus 1 over 2, of course you multiply 1, multiply 2, that's 2 plus 1, 3. So this one will be 3 over 2, multiplied by 1 multiplied 3, that's 3 plus 1, 4. The second one will be 4 over 3, multiplied by the third one will be 1 multiply 4, 4 plus 1, 5. This one will be 5 over 4. And you will see that the numerators are in ascending order from 3 going upwards. The same applies to the denominators. They are in ascending order starting from 2, increasing by 1. And our last term, since the question says it is 1 plus 1 over n, so we multiply 1 multiply n, that's n plus 1 is going to be n plus 1 over n. This is our last term. And you will see that if you look at the first numerator, which is 3 of the first fraction, and the first denominator of the second fraction, it is 3. They are the same. So this 3 will cancel with this 3, and this 4 will cancel with this 4, and this 5 will cancel with the denominator of the next fraction, which will be 5 obviously, and it will reach to a stage where this n, our denominator, is also going to cancel with n on the second last term. So what's going to remain as a numerator is n plus 1, and as a denominator is going to be 2. So this will simplify into n plus 1 divided by 2. And since, according to our question, n has to be greater or equal to 2, n plus 1 over 2, since 2 is an even number, for n plus 1 to be divisible by 2, n has to be an odd number, because if you add an odd number and an odd number, you get an even number. And since our n has to be greater or equal to 2, this implies that n is odd and n must be greater or equal to 3, because the first odd number bigger than 2 is 3. So n could be 3, could be 5, could be 7, and so forth, as long as it is greater or equal to 3 and it is odd. So that's it for the first question. We are going to continue on with the second question. And please don't forget to subscribe, like, and share the videos. See you in the next question.